Deep beneath the surface, light has already surrendered. Pressure presses like a remembered weight. Silence hangs, and a shape floats that should not be seen. It is almost invisible, an outline that blinks only because a single bioluminescent spark flares and dies. Our lights touch it, and still it nearly vanishes. The ocean has become a room without walls, and something beyond our sight drifts through it. Here, in the dim threshold, where the Twilight Zone gives way to the Midnight Zone, survival is written in absence. Creatures have learned to erase themselves, in body and in behavior, so that a passing eye will find nothing to follow. The water is thick with blackness, yet it shivers with tiny points of blue and green, like distant stars watched from the bottom of the sea. Those points are both signals and masks, bioluminescent language that can reveal or hide. Music. Why does life choose to become a ghost? The answer is not poetry. It is simple, brutal ecology. To live here, you must not be seen, or you will be eaten. To hunt here, you must not be seen, or your prey will not come within reach. In the cold, low-energy world of the deep, every saved calorie matters. Invisibility is not style, it is survival. Some bodies are transparent to the last filament, fibers and tissues arranged so light passes through without scatter. Others wear ultra-black skin that swallows every stray photon, a velvet so deep that even a camera records only absence. Some animals produce light on their bellies, matching the faint downwelling glow, so their silhouette disappears in a trick called Counter-Illumination. Still others are effectively invisible to red light, a longer wavelength that stops being useful in the depths. Gelatinous bodies bend and diffuse light, while specialized tissues can refract or guide rays around a form, like water bending light around a held shape. Each adaptation is a different path to the same place, the place where detection fails. Descend further, and the zones change names but not the law. In the Twilight Zone, camouflage and shadow play dominate. In the Midnight Zone, absence of light becomes a living condition. In the abyss, pressure and scarcity favor slow, efficient lives that vanish beneath any glare. In the Hadal trenches, darkness reaches an almost geological permanence. Across these zones, invisibility is a strategy that shapes entire communities and controls the food chain. Predators use stealth as geometry. They time a flash, they angle a light, they become a living trap. Prey become strategies of disappearance, ghosting away in transparency or dissolving into the blackest skin. Even modern submersible lights can fail to compel these creatures into view. Some simply redirect light, others absorb it, and some change color so rapidly that the eye cannot hold a contrast. The result is a theater of absence, a world where seeing is the exception. And yet, the greatest tension is this. Evolution has pushed invisibility to extremes we barely understand. Why did some lineages evolve tissues that guide light like optical fibers? Why do certain species possess skin that reflects nothing at all? There are adaptations under study, molecular tricks, and microstructures that bend physics in ways we cannot fully explain. The deep keeps its secrets, and our instruments only scrape the surface of a deeper mystery. We begin here, in a place where bodies are vanishing, and questions outnumber sightings. The depths are not empty, they are full of forms that refuse to be seen, and of science that must find new ways to look. The ocean hides more than it reveals, and the invisible creatures that roam its darkest realms remind us that there is still much we have not yet discovered. In a quiet laboratory, a sphere of transparent gel is lowered into a tank of seawater. The moment it enters, its outline blurs, then dissolves. What began as a distinct form becomes almost imperceptible, erased by the water that surrounds it. This is not an illusion, but a demonstration of physics. The gel's refractive index, nearly identical to seawater at n equals 1.33, bends and transmits light so precisely that it vanishes from sight. Under these conditions, even the sharpest camera lens can barely distinguish gel from water. Nearby, a second experiment unfolds. A sliver of deep sea fish skin, studied by Joanna Eisenberg's team, rests beneath a beam of white light. Most surfaces reflect a small fraction of this light, but here, the beam appears to disappear. Electron micrographs reveal why. The skin's surface is packed with elongated melanosomes, arranged with such density and order that over 99.5% of incoming light is absorbed or trapped, never returning to the eye. On a reflectance graph, the line flattens near zero. The surface behaves like a photon trap, a technology evolved by creatures to swallow light. These controlled tests, Johnson's vanishing gel, Eisenberg's photon trap skin, transform the abstract into the observable. The principles that govern the deep sea's invisible creatures are proven here in glass tanks and under electron microscopes before they are ever witnessed in the wild. What seems like magic under the ocean's pressure and darkness begins as a matter of optics and adaptation, made visible only through the language of science. Light in the deep ocean is not just scarce. It is altered, stretched, and fractured by water. Most eyes below 1,000 meters are tuned to blue, the only color that penetrates this far. Yet some predators have learned to see and to emit red, a wavelength that vanishes for almost every other animal. The stoplight loosejaw, Malacosteus niger, produces a beam of deep red bioluminescence. To its prey, the darkness remains unbroken. To the loosejaw, red reveals what blue conceals, a secret searchlight invisible to all but the hunter. Gelatinous bodies take the idea of invisibility to its logical extreme. Ctenophores, salps, and siphonophores are constructed almost entirely from water. Their tissues so dilute that a passing current can blur their outlines. With water content exceeding 90%, these animals float nearly weightless, lacking the dense muscles and bones that would betray a shape. Their surfaces bend and refract light, softening edges until structure dissolves into the surrounding sea. Edges are liabilities in the deep. Evolution favors creatures whose boundaries dissolve. Some species, like the glass octopus, soften the transition between tissue and water by creating subtle gradients in refractive index. Others scatter light at their margins, erasing the hard line that would give away their presence. In a world where a faint silhouette can mean the difference between food and being food, minimizing contrast is life or death. Counter-Illumination is another toolkit for disappearance. Many midwater animals carry bioluminescent organs on their undersides. When seen from below, their glowing bellies match the dim light from above, and they vanish against the sky. From above, other animals see only an empty patch of ocean. Counter-illumination is both camouflage and disguise, an active painting of light that cancels an animal's outline. Some deep hunters have gone further, exploiting wavelengths the rest of the world cannot detect. A few species have visual pigments sensitive to red, and they produce red light to reveal prey that remain blind to that color. Red light invisibility turns the darkness into a private channel for the hunter, a hidden beam that outlines movement while the rest of the community remains oblivious. Light bending and ultra-transparent tissues are complemented by ultra-black skins on other animals. Where transparency cannot be achieved, some species absorb nearly all incoming light, creating a surface so dark it erases reflections and removes cues about shape. Ultra-black is not simply dark pigment, it is tissue organized at microscopic scales to trap and scatter light inward, preventing any hint of shine or silhouette. These strategies are not mutually exclusive. A gelatinous body may be very transparent and also display counter-illumination. A predator may use red searchlights while its flanks remain ultra-black. The deep ocean is a laboratory of overlapping adaptations, each one tuned to reduce contrast and to steal concealment from light itself. The result is a world of partial presences and vanished forms. Under even powerful submarine lights, some animals refuse to reveal themselves. They bend light, absorb it, emit it, or avoid reflecting it. For many species, invisibility is not an aesthetic choice. It is necessary for survival. Movement is expensive at depth, and being seen can end a life. To hide is to live. Even as we decode these toolkits for disappearance, questions remain. How do microscopic structures in skin evolve such precise optical control? Which genes orchestrate gradients in refractive index? Why do some lineages favor transparency while others evolve ultra-black? These are active frontiers where biology, physics, and chemistry intersect. For now, the deep keeps its secrets. Light is a currency down here, and life spends it in strange and elegant ways to remain unseen. The invisible toolkits of the deep are both answer and puzzle, proofs of survival and reminders of how much remains unknown. At the edge of the Twilight Zone, a glass squid hovers in the suspended blue, its body nearly invisible against the water's dim glow. Darkness presses from above and below, pressure that you can feel in the silence. Faint sparks of bioluminescence pulse like distant stars, and each spark can reveal or betray. Sunlight still seeps down in fractured shafts, and every living shadow risks being revealed. The greatest hazard here is not the predator itself, but the silhouette cast against the faint shimmer above. A single dark outline can mean instant detection. Along the squid's ventral side, rows of photophores ignite, casting a faint living mirror of the light overhead. This is Counter-Illumination, a camouflage measured in fractions of a second, tuned so finely that the squid's belly and the water above become indistinguishable. The illusion is shaped by brightness and color, by timing and angle. The squid matches intensity, it matches hue, and it matches pattern, until the eye above sees only the dim, uniform twilight. The timing of this illusion is a matter of life and death. Laboratory studies have measured the squid's neural response at a few hundred milliseconds, fast enough to track gradual shifts in twilight, but never quite instantaneous. Some experiments in American and European labs have recorded delays as short as 200 milliseconds. Other experiments have noted reaction times as long as 2 seconds when light changes abruptly. In the wild, a passing cloud or the flicker of a predator's searchlight will test the squid's control. For a heartbeat, a vulnerable outline appears before the photophores recalibrate. For a cephalopod, lingering in the twilight is a high-wire act. Every muscle, every nerve is tuned to the rhythm of the fading sun. The cost of hesitation is exposure. The reward for perfect timing is survival. Here, camouflage is not a static trait. It is a living negotiation with shifting light, carried out in the narrow margin between seen and unseen. Descent brings silence so deep that even the hum of machines is swallowed. A research submersible hovers in the dim blue, its sensors straining for any trace of life. Then, a warning light blinks, the filter wheel is jammed, and the optical sensors are flickering. The engineer's voice, steady but tense, describes the challenge. At these depths, even the smallest flaw means blindness. Salt crystals, a grain of sediment, or a shudder from the cold can freeze a camera's vision. The team swaps out filters, recalibrates the system, and waits. Minutes pass as the sub drifts, nearly motionless, in the slow, cold current. In the control room above, an abyssal biologist studies the sensor feed. She notes the paradox. The creatures here are invisible by design, yet the technology meant to reveal them is nearly as fragile as the bodies it seeks. Standard imaging fails against ultra-black skin, which absorbs nearly all light, and transparent forms that scatter beams until only a faint shimmer remains. Even advanced cameras, SCMOS and EMCCD, struggle to capture a boundary or a shadow. Sometimes the only sign of life is a distortion in the water, a sluggish drift where a siphonophore or catennophore moves, nearly indistinguishable from the current itself. Energy is rationed with the same precision as light. Gelatinous animals, with bodies composed of more than 90% water, move slowly to conserve every calorie. Muscles are sparse, nerves minimal, every action weighed against the cost of survival. In this world, both animal and machine are tested by the same forces: pressure, darkness, and the need to see without being seen. Deep below, even the act of watching must become invisible. Standard submersibles, with their bright lights and humming motors, often announce their presence long before any animal comes into view. Edith Widder recognized this problem after a failed camera deployment in 2005, when the glare of artificial light scattered every living thing before a single image could be captured. She began developing passive imaging rigs, systems that sit silent and dark, recording only the faintest glimmers of bioluminescence without disturbing the water's delicate balance. Her Eye in the Sea device, lowered quietly to the seafloor, waits in darkness, letting the ocean reveal its secrets on its own terms. Through this approach, researchers have observed authentic displays of counter-illumination and stealth that would vanish under even the softest spotlight. In the deep, technology must learn the same lesson as its subjects. To survive, it must disappear below. 8,000 meters, the ocean becomes a realm of shifting shadows and unanswered questions. The light is gone, pressure is absolute, and silence presses against the hull like a memory. Faint sparks of bioluminescence puncture the dark, then wink away. In that dim, invisible world, something is there, and it refuses to be seen. Jamstek's Hadal landers, fitted with ultra-sensitive cameras, have recorded movements that are at once haunting and unexplained. On the screen, a suggestion of form, a smudge at the edge of the frame, a body that gives no clear outline. The object drifts. It pauses, then it dissolves into the black, as if the ocean itself were swallowing its shape. No specimen has been retrieved. No genetic sequence has been mapped. The footage is often grainy, haunted by distortions born of extreme pressure and cold. Yet the patterns persist. A flicker, a shape, a vanishing. Some scientists suspect artifacts of light and lens, illusions born of the trench environment. Others argue the evidence is consistent and that we are witnessing something real, entire lineages of life that elude our nets and our instruments. The trenches are not forgiving to cameras or to flesh. Instruments creak and warp, sensors drift, memory cards fail. Still, the same rhythm of motion returns, like a phrase repeated at different tempos. Each faint trace raises the same question. Are these shadows merely gaps in our vision, or are they the first signs of organisms that have perfected invisibility to survive where sight itself is a liability? The next generation of AI-powered probes is scheduled for full deployment in 2025. These machines promise longer endurance, smarter sensing, the ability to follow a faint signature without blinding it with light. They will scan the Hadal depths with new algorithms tuned to detect absence as much as presence, to distinguish true living form from the trickery of optics and pressure. Until they arrive, the Hadal Zone remains the ocean's last blind spot. It is a place where invisibility is not merely an adaptation, but a barrier to knowledge. Where absence on our screens may mean absence in nature, or may mean only that our tools are not yet worthy of the deep. The trench shadows hide their rules, and for now, they keep their secrets. The mystery endures. Down there, beneath 8,000 meters, the balance of life is written in light and the lack of it. Predators and prey negotiate survival with gifts of transparency, ultra-dark skin, and bodies that bend light until they are gone. Evolution has driven extremes so complete that to glimpse them we must first learn to see the invisible. And so we return, again and again, to the rim of that abyss, instruments in tow, compelled by a simple, stubborn desire. To know what cannot be seen. To map the shape of absence. To learn why entire forms of life chose disappearance as a strategy for survival. The trenches keep their shadows. The ocean keeps its mysteries. For now, invisibility is both a refuge for life and a riddle for science. The answers lie deeper than our brightest beams, and they will require patience, courage, and instruments that listen as well as look. The Hadal remains, in the truest sense, unknown. Even now, over 80% of our ocean remains unexplored. Deep underwater, pressure and darkness fold around the hulls of our vessels, and silence presses in, broken only by faint sparks of bioluminescence. As new probes vanish into the trenches, each discovery only deepens the enigma. We glimpse a shape, a shimmer, a transparency, and the ocean closes its curtain once more. Invisibility is not just a trick of light. It is a matter of life and death, a strategy honed by millions of years of selection, and it remains an unanswered question. The ocean's hidden life reminds us the greatest mysteries may be the ones we still cannot see. We leave these depths not with closure, but with a renewed sense of wonder. The trenches, the midnight zone, the abyss, and the Hadal depths still hold beings that vanish beneath our lights, and adaptations we do not yet fully understand. Exploration will continue. New senses, patient observation, and humility before an environment far older than our instruments will bring more revelations. Yet some answers will elude us, and that is part of the ocean's power. The sea keeps its secrets, and in that darkness, life has learned the art of disappearing. For now, those vanishing acts are a reminder and an invitation. Keep searching.